Namaskar, sir. So, my name is Rishikesh. My roll number is 20057, and I am going to take the topic Links Taxonomy in the field of computer organization and architecture. So, let's get started. So, the summary of today's topics will be Introduction to Flynn's Taxonomy, Parallel Computing, and the classifications. That is the main thing about the Flynn's taxonomy. Then there will be the conclusion. So let's get started. So, introduction to Flynn's taxonomy. Flynn's taxonomy was proposed by Michael J. Flynn in 1966. So it is actually a classification or the way how to divide a computer system or how to make a computer system based on certain certain amount of features, and that can be the classifications that is based on the number of concurrent instruction and data streams available in the architecture. So that means the classification in the Flynn's taxonomy, the Michael J. Flynn actually have divided the making of a computer system into four main classifications. Now, these classifications are actually made on the basis of the two main wordings or technologies, that is data stream and the instruction stream. So based upon the data stream and the instruction stream in a computer system, they can be classified into four other systems. So when we go deep into it, the actually, first of all, what is instruction stream and data stream? That's the first question. So instruction stream is a sequence of instructions read from the memory. So what the system read from the memory is called instruction stream, that contains the opcode of what should be done. Sorry. Then we have the data stream. Data stream is actually the flow of operands. So flow of operands, or what to say, the numbers or the values upon which the operations are done. Those are called the operands. So these operands are taken from the main memory to the processor, and this pool of data is called the data pool or the data stream. So these two main terminologies are actually coming into existence in case of a Flynn's taxonomy, that is data stream and instruction stream. So actually, it has been used as a tool in the design of modern processors and functionalities. Now, moving on to one of the major component of Flynn's taxonomy, or based upon which the Flynn's taxonomy is working, is parallel computing. So parallel computing is computing where the jobs are broken into discrete parts that can be executed concurrently. That means the job of a system or the job of a processor in order to process is actually split up into multiple different layers, so that the system can actually work on each of these parts concurrently. That is, these further broken down, these parts are actually further broken down the series of instructions. Now that's where the term instruction stream comes into. So each part is further broken down into a series of instructions. The instructions from each part are executed simultaneously on different CPUs. Okay, now we tell the term different CPUs, although we say that actually when we go deep into the working of parallelisms, we find that the parallel systems deal with single computer with a multiple processor. That's one possibility. Several computers connected by a network forming a parallel processor, or the combination of both. So it can be anything parallel. That is a single system uh, having multiple CPUs, or parallelly connecting single CPUs in a chain that produces parallel computing, forming a cluster, obviously. So that can be anything. Any of these combination, either of these combinations can be used in the case of a parallel computing. Now, for our topic, the Flynn's classification, what are they? What is Flynn's classification? That's our question. So these four things are the main Flynn classification. So classification number one is called SISD. Classification number two is called SIMD. Classification number three is called MISD. And the fourth one is called MIMD. So four main classifications depending upon the instruction stream and data stream. So single instruction stream, single data stream, multiple instruction stream, multiple data stream, single data stream, multiple instruction stream, single data stream. So these are the four classifications, and we can see certain examples. Now we will be explaining each of these topics individually. So topic number one is SISD. In computing, SISD, the single instruction stream, single data stream, is a computer architecture in which single Unicode processor executes a single instruction stream. So it's basically our basic computer that we learned. That's the von Neumann architecture. We can see here. It corresponds to the von Neumann architecture, and it operates upon a data stored in a single memory. So it's one-to-one function actually what is working there. And we can see the diagram here where the data pool and the instruction pool is directly a single, is essentially just a single set of instruction and a single set of data pool upon which the processor is acting, and they are the normal basic von Neumann architecture. As we can see in the systems, the classifications are based upon the number of concurrent instructions and data streams present in the computer architecture. So the instructions are sent to the control unit from the memory module and are decoded and sent to the processing unit, which processes on the data retrieved from the memory modules and send back to the memory. Yeah, that's basically what you say of the von Neumann architecture. Uh, we get the instructions from the instruction pool or the memory. We also have the data inputs, and according to the instruction and the data received on the instruction, there will be a processing done, and we'll get the output, and that will be sent back to the main memory. That's it for the basic SISD. Now moving on to the second type of Flynn's classification, that is the SIMD. That is a single instruction, multiple data. That is a type of parallel processing in Flynn's taxonomy. So parallel processing from now on comes into existence. That is, SIMD describes computers with multiple processing elements that perform the same operation on multiple data points simultaneously. So what we have here is multiple instruction streams, we can say. Actually, multiple data. The instruction stream is single, but multiple data we are getting. We are getting a multiple number of data. So these multiple data are actually handled by a single instruction. Say for we have multiple, uh, if you are telling multiple students in a class, so we need to find the average marks of each of them. So in that case, it's just a parallelism. So in that case, the instruction is basically the same. We are having the single instruction to count each one of them's mark and take the average. Suppose each one of them is having an 80, 90, some kind of 5 marks out of 100. We add them and simply divide by 5. That is instruction. So that is same for everyone. But what if we have 4 students? So for 4 students, we need for and to find the answers concurrently, we need 4 different data pools. So 4 different data are coming into existence. But the processor is actually executing this based on a single instruction. So SIMD describes computer with multiple processing elements, so that have multiple processors basically that perform the same operation on multiple data points. Such machines exploit data level parallelism. Data level parallelism, that's another terminology. There are simultaneous parallel computations, but each unit performs the exact same instruction at any given point of time. The most modern CPU designs include SIMD instructions to improve the performance of multimedia use. So in case of multimedia usage, they use SIMD processors. So that's about SIMD. Now moving on to the third classification is the MISD. So in computing, MISD, or the multiple instruction single data type, It is actually again a parallel computing architecture where many functional units perform different operations on the same data. Tolerance executing the same instructions redundantly is in order to detect and mask errors in a manner known as the task replication may be considered can be considered to be this type. Okay, so that is we are having the actually the opposite of the SIMD. The instruction is actually the same. Actually, we are getting the multiple type of instruction, but the data pool is actually the same. The same data is actually flowing through. That's again a parallel processing. So instruction is not same. Instruction is multiple. The data is same. Actually, we are having a single type of a data. A single flow of data is the same data. Basically, the same data. That's a data pool. Then we have the instruction pool. The instruction pool basically tells multiple instructions or gives different types of instructions to work upon the same data. So that is one example given there, fault tolerance executing. So in order to find errors, we actually work on the same code again and again, but different types of instructions. One will be checking for any errors, one will be checking for any syntax, like that. So multiple instructions will be given, but they are working on the same data pool. That is the main thing about MIST. Applications for this architecture are much less common than MIMD and SIMD. Yeah, that's one major thing. However, one prominent example of MISD in computing are the space shuttle flight control computers. So they are actually used in space shuttle flight controls, MISD. Okay, then we have the MIMD. The MIMD in computing has a multiple instruction, multiple data type. It's a technique employed to achieve parallelism. Now we have reached the state of complete parallelism. So in this case, machines using MIMD have a number of processors that functions asynchronously and independently. Now we don't have to worry about the concurrent or the same pool of data, so that the data reaches according to base kind of a timing will be there in single types, but we are having multiple. So for each data pool, there's coming a different instruction, we can say. A different type of data are going into different type of instructions. So basically the picture you can see here, instruction pool and data pool. Now MIMD machines can be either shared or distributed memory categories, that just the memory hierarchy. Then shared memory machines may be bus based, extended or hierarchical type, that is shared memory, but the distributed memory may be a hypercube or a mesh interconnection streams. So they are actually based upon the connections that we give upon them in order to get the data from the memory. That is, the shared memory may be bus based or the hierarchical type, and the distributed memory machines may be interconnection schemes of hypercube or mesh. So in this type, we basically see the instruction pool giving multiple instruction to multiple datas. So, and it does not actually have to depend upon any other factors. Each of them is doing their own jobs. Basically, we can say about this MIMT, and it is a most useful thing, most useful architecture in when it comes to the Flynn's taxonomy or the Flynn's classification. Now, before that, I have to just mention about the examples. So, as I said, SIST, the von Neumann architecture, the uniprocessors, single data, single stream is example of SIST. Then SIMD is parallel processors or vector processors. Then MISD may be pipelined computers. That is another terminology used in pipeline. Then MIMD is multi-computer multiprocessors. So multi-processing, essentially we get it from the MIMDs. Now moving on to the conclusion part and the last part, the biggest problem is that Flynn only provides 4 slots to plug systems into. That means only 4 types of classifications are given by Flynn. So that is a issue, because there are tasks which does not fall into any of this either of these four categories. So what we can do in that case, that's an issue. The problem is further excalibrated by the incapability of MISD and the demise of SIMD systems. Now, the SIMD systems are very useful, but actually they are not nowadays used. It is mainly because of different classifications brought after the Flynn's taxonomy that actually led to the complete overturn. But we can say the Flynn's classification is the base of everything. But there are actually different and many useful, like you can say Dukan's classification. Many different types of taxonomies have come after the Flynn's taxonomy, which is actually nowadays used. But this is the basics, like we say about a von Neumann architecture. Then the same operation on multiple elements can be performed using one instruction only. Throughput of the system can be increased by increasing the number of cores of the processor. Yes, so that's an advantage uh, of the Flynn's taxonomy, or a system working on the Flynn's classification. So actually this Flynn's classification is used in order to create, or which actually led to the creation of these latest multiprocessing technologies. So what Flynn explained even 50 years back were used in order to make the current systems, and still it will be considered to be the basic upon which a computer architecture engineer would start to build a system, uh, depending upon the Flynn's classifications. After that, actually further classifications came, but still the Flynn's taxonomy, as I said, would remain as the basics. So that's all for Flynn's taxonomy, and thank you, Namah Shivaya, sir. Okay, thank you.